Hello everyone. In class the other day, somebody asked about how the enhancers here, how they influence Ifg2 expression, how that is related to the way that DMR1 and DMR2 interact with DMR in the looping. And so I thought I would take just a few moments and present a short podcast explaining how the two of these regulatory mechanisms work together. So what I've drawn here is the maternal component of Ifg2. Remember, Ifg2 here from the maternal source is turned off. It contains two DMR regions, D1 and D2. It contains a D0 as well, but we're not going to focus on that one. Maternally, these are not methylated. The H19 produces a non-coding RNA, and when the DMR is not methylated, CTCF binds to it to turn on transcription of this non-coding RNA. Now, in this arrangement, I told you that the enhancers cannot interact with Ifg2. In another slide, I told you that in the maternal source, D1 interacts with DMR. DMR1 interacts with DMR. And so I think we'll be able to see, if we draw the loop with the enhancers, we'll be able to see how they are unable to affect Ifg2 expression. So down here, we see DMR binding to CTCF and then interacting with DMR1. There's probably a protein involved here, but we're not sure if it is or what it is. But we do know that DMR through CTCF interacts with DMR1 of the Ifg gene. We said over here is the inactive domain, and over here is the active domain. Ifg1 is in this inactive domain, so it cannot be expressed. The way it's positioned, transcription factors cannot get in here. In addition, you can see that the enhancers over here are unable to interact with Ifg1. The way enhancers usually work is that proteins bind to them, and then they come in contact with the gene, with the promoter of the gene. The promoter of this gene is now locked up here. Ifg1 is shut off for two reasons. The first reason is because DMR binds to DMR1, keeping the Ifg1 in this inactive domain where transcription proteins don't have access to the gene. In addition, the enhancers here are not able to interact with Ifg1 to help the expression of the gene. So Ifg1 is effectively turned off. Now let's look at the paternal component. Okay, so here is the paternal component of Ifg2. Ifg2 from the paternal source is expressed. H19 is not expressed. CTCF cannot bind to the DMR region because it is now methylated, which causes H19 to be off. Now, what I've told you before is that now the enhancers can interact with Ifg2 to help activate it. I also told you that DMR here will now interact with DMR2 of the Ifg gene. And it does that by looping around. So let's, like we did before, let's show the loop, and then we'll be able to see how these enhancers are now in a position where they can affect the transcription of Ifg2. So you can see now that DMR of the H19 gene, it's not methylated, so it can't turn on H19, so H19 is off. DMR now interacts with DMR2 of the Ifg gene. It is certainly likely that there are proteins that help mediate this interaction, but we don't know what those proteins are. I should have also mentioned up here that DMR1 and 2 are likely methylated. I say likely because when I look at the literature, I see some evidence that suggests they are methylated in the paternal source and some where they're not methylated. So it seems at this point it's unclear. So I won't ask on an exam whether or not DMR1 or 2 are methylated. What I really want you to know is that DMR1 and 2 regions here of the gene interact with DMR of H19 in a way that determines whether or not it will be expressed. I would not worry about whether or not DMR1 or 2 are methylated. DMR you should know. Okay, so let's come back here. DMR2 is interacting with DMR, and that causes this whole loop to shift. And as it shifts, it moves DMR1 over here. It exposes the promoter area. Now, transcription factors can come in here and activate the transcription of this gene. because it's now in the active domain. In addition, remember when DMR interacted with DMR1, the gene was in this inactive domain and the enhancers didn't have access to it. But now, enhancers and the proteins that bind here could easily interact with proteins that bind to the transcription factors to help stabilize that interaction here and to help drive the expression of this gene. So again, DMR binds to DMR2, shifts the gene to the active domain, allows transcription factors to come here and drive the expression. Enhancers are now closer to the promoter in a way that they would be able to presumably interact with the promoter of Ifg2. Okay, I hope that helps bring these two concepts together, but if it's still unclear, please make sure you come talk to me, and I'll help you understand it better. All right, I'll see you in class. Bye.